Well, kia ora. This is my new lecture setup, and I'm hoping that means it'll do a better job of recording than my previous attempts at videoing effectively a TV screen. So this is a talk that I gave in Delft in the Netherlands, and it focuses on the use of water as the motive power of the gold rush. Not just the motive power, but the power for everything. So one of the things I want to deal with in each of these is basically undoing some of the myths of the rush, and to that end look at some of what you've possibly been told and undo it. So the first thing is to look at the visual representations of the rush. So there we've got Eugene von Gerard's quite iconic picture from Australia called I Have Got It, and another one here from the Victorian goldfields by S.T. Gill, probably Australia's most iconic goldfields artist. And the idea here is they're depicted always with a pan laden with gold, and they might be the same picture here. These were Victoria, but the same picture might apply to Doctor's Point, it might apply to Skipper's Canyon, it might apply to Bathurst in New South Wales. But the depiction is always showing them with a gold pan. The reality is that method of gold mining did not last very long. For one thing, it's really hard work. Secondly, if you're on good gold, it's quite slow to get it. I mean, yes, it's nice to get a lot of gold out of a pan, but you get to the point of thinking there's got to be an easier way, and there was. Quite simply, there were a number of techniques, so this one's probably a little bit out of order because this developed a little bit later in the rush, but these are what's called what's called a wing dam is built. So you've got you're on the edge of the river, and so you've got your river flowing through here, you've got your claim on the edge of the river, and quite simply you build a dam out into the stream, and then you pump it dry and then work what you've got behind the dam, the gravel, for gold. Two techniques depicted here. One is what you'll see if you visit Ballarat's Sovereign Hill, and that is a hand cranked pump, and the idea here very simply is this pulls water up and out. They call that a Californian pump. It wasn't. It was a Chinese pump. But of course, the, should we say racist, prejudiced, bigoted, whatever, all of them are correct, miners in California could not abide the idea of acknowledging Chinese expertise, so of course this became known as the Californian pump. So we've got one here where he's hand cranking it and lifting the water out over the dam and into the river, and simultaneous with that they've got water flowing that they can dump the gravel into. So they've got what's called a long tom sluice box here, and he's putting the gravel into there, that's washing out, and he's keeping it dry. Up here they've got even smarter. This is done by Andrew Swift, who's quite a talented artist in Victoria, and what he's shown is instead of a hand cranking, they've actually rigged up a water wheel that is actually turning the handle of the Californian pump here and keeping it dry. So what that means is you've got someone shoveling out the dirt behind the dam, and someone here is bringing spoil from presumably another claim. So that's a water power. So what we're doing there is we're utilising the fact that water deposits gold, because gold, as soon as it hits any change in velocity, particularly slowing down if it hits. So here we've got a point running down to the river, change of velocity, deposition of gold, and so they've recognised that and built their wing dam there. This is the most popular one, though, method that uses water that has one miner involved. So if you look at this is involving quite a lot of technology and quite a lot of time. So if I had arranged the slide right, and I'm not quite sure how that got out of line, but anyway, this was the first step from panning. So you use your pan to find out, is this good gravel? good land. Is this claim worth me spending time on? And so if the answer is yes, you quickly employ this, which is called a cradle. Cradle, very simply, you put the gravel in the top, you then use a scoop to pour your water in, and this here basically has holes drilled in it, and all the rough gravel stays out, basically is caught by the filter, if you like, and the gold and fine gravel drops through. Eventually you could see this is hinged, you'll tip that out and the waste goes out, and then there's two slides here that each have riffle bars on it, and the riffle bars basically are just little pieces of doweling or sticks that interrupt the flow of the water, and the gold stays behind that. And every so often you empty those out and collect all your gold, and then you use your pan to sort that out. You get your fine sand and the gold, you get rid of the sand part and you're left with just the gold. So this guy here, this is in the late 1880s. It's not that good on the focus on here, but in here you've actually got a couple of old dredge buckets, so that's how we know the date of that. Always be suspicious of photographs. What are they trying to depict? In this case, this was a photograph taken by Reverend McFlurry who was with Reverend Don, and McFleur, who was with Reverend Don. The idea here is give us money so we can preach to the Chinese miners. So, because photographs are expensive. This was using what I made a reference before to a long tom. This is a long tom in the stream. Now, long tom is what you may also hear of called box sluicing or sluice box, or as I say, long tom. But the idea here is this is made of a U shape, and in the bottom of it, it has a series of what's called riffles, and then at the end it'll have moss tamped down. And the idea there is that you dump the gravel into the flow, the river is flowing down, you've focused the flow onto that, gold being heavier, drops down, is caught by the riffle bars, the gravel being light is washed out, and at the end of the day you've got your gold collected there. The moss at the very end was to catch the fine stuff, and there was sphagnum moss, things like that. It was very good at catching the very fine gold, particularly on the west coast. So you can really get a lot of volume, because all you need to do, if you've built it right and got the slope right, which was actually quite critical, you really can work all day, because you've got three guys here in this depiction. This is actually 1898, so in the Mulgrave in Queensland. But three guys shoveling, you are going to process a huge amount of material over a day. Key here, getting rid of what will accumulate this. This is what's called sludge, and I'll make some reference to that later, but getting rid of the increased volume here actually became an issue, particularly if you imagine these guys weren't the only ones doing this. Puddling, you will read about puddling, and as something that miners did. They didn't tend to do it in New Zealand. So this here is a puddling machine, and basically what you do is you put a slurry of clay. So the clay was it was almost a concretion, but as soon as you put water on it, it breaks up. Problem, if you've been to Australia, I mean, the problem is always shortage of water. So what you can do is you can put a lot of clay in there that's got gold in it. You've dug it up, you've got this concretion, you dump it in there, add water, and basically the horse is going round and round and round, and this is dragging some weighted sort of rake-like things that break it up. And it breaks the clay up, and eventually you're left with a gold-bearing sludge in the bottom. The trick there is being able to pump it out and sometimes even reuse the water or cleanse the water. If you sit it for a while, the particulates will drop out of it and you can reuse it. Here, this is the only thing that looks like a puddling remnant in central Otago. This is up on Old Man Range. I'm slightly suspicious whether it was a puddling machine. I can understand why they would do it. There's no water at all up there. So if you had concretions up there, if you had clay that was bearing gold, then you would build a puddling machine. But part of me wonders if this is just the means by which you made mud bricks so you can build a house. So again, I'm just slightly suspicious of that, but for now we think it was a puddling remnant, partly because there's no house around there. Probably miners living in tents. I'm going to do another presentation on what the miners lived in. So yeah, we'll have a look at that. So here's when you get into the big time, you will hear about something you will sometimes read called hydraulicking. Sometimes it is called ground sluicing. Sometimes it's just called sluicing. It's all sorts of things. But effectively, you've got two things going on. One is you are getting water at pressure on gold-bearing strata. This is at Blue Spur, so you've got deposition in an ancient lake over millennia that contains gold. So your goal here is to get water in the quantity you want, directed onto the face, whereby the gravels and gold flow down, and then you get it flowing down here, and right there you have a riffle box again. You'll read these different things. Water race, tail race. Technically that's your tail race that's collecting the end result. And these could be quite long. These could be, I've seen one that was 25 metres long. So they were quite important. And the whole idea is to get, you can imagine all of this has got gold deposited in strata, but thinly deposited. If it was thick, you just mine it. Gravels can be mined. I mean, if you look at the Ballarat Plains, gold was taken out of there, out of the gravels. If you visit Sovereign Hill, I've actually got very good representations of what goes on there. By the way, our local one, there's two New Zealand visiting mine representations I recommend. One is in Thames. They've got an old quartz mine there that you can go through. Fantastic place to visit. And of course, Shantytown on the west coast is still brilliant. Go there. You can actually have a crack at mining, panning, and yeah, it's a good place. Anyway, so what we've got, so again here you'll notice that I make mention of sludge. So you've got gravels flowing down here, through there, drops the gold out and out. Now in New Zealand, we designated, instead of like Australia, they would actually dig out sludge channels, and they would call them sludge channels, and there is some very, very good work has been done over there with examining old sludge channels. But here, what we did is we designate the local river as a sludge channel, and the gravels were simply dumped into it. Now, that made for some problems in the future, as I'll show you. But how does it start? Well, to get water to here is a very complex process, certainly a very complex engineering process. So it starts here. This is the only, and I didn't even know I was taking a photograph of this at the time, I'd have to admit. This is the only time I've ever seen it, and you can see this is up on the Criffle Range, Central Otago, you can see that stream running. Well, at some point in the 1870s, you can see just there, and I apologise, it might not be that clear to you, but someone has cut a channel, and that is the most important cut of all, because that is what defines the water right. And the water right was measured in sluice heads. Sluice heads about 168,000 gallons per day, and these were defined in numbers of sluice heads. So this is quite small. This is about 2. sluice heads, but they cut the channel and it's measured here. So your water right is based on where you take it, not where you use it. If you cut it, if your water right is for 4 and when you use it you've only got 2, the extra 2 can actually be reallocated to someone. So what there was quite a strong incentive to use your water efficiently. So anyway, they've cut this, here's where you measure it, and then the water race, can you see this line here, is actually the water race they built. So they've dug that, that's a reasonably rocky terrain, so it would have actually not been too bad to dig. So that was where it was inspected though, and as I say, along the water races it could be checked. So cost, now if you look at this one, this is straightforward. I've said that it's straight, well that one's not straight, but that one's, again it's a 2-head race, so it's not too bad, but this is just by Lauder, and you can see some dredge tailings over the back there, by Lauder in central Otago, just outside of Alexandra, and so something like this, all you're doing is you're cutting a ditch. And this is a mining water race. There's actually about 3 in this paddock. There's one over here as well. And this would cost about £60 per mile. Now some of these races were 12, 13 miles. And that's about 15,000 in 2015, probably not much more now in 2020. But if this was flat, you get your water, you get it. Now you'll see it follows the contours. It's not straight for 2 reasons. I'll come back to that. But it follows the contours of the hill. Your water race had to be cut so that the fall was between 4 and 8 inches in a mile. Now 4 to 8 inches, 4 inches, 8 inches. And that's the whole fall over 1.6 kilometres. So that's precise engineering. Now, if you're cutting this and you hit gorges, ravines, bluffs, or whatever else, or there's steep terrain, or there's scree slopes, or whatever, you're up for some serious expense. You're spending £60 a mile on a, say, a 10-mile water race. That's £600. Now you think, oh, what's that? A teacher in the time of the rush for gold earned about £100 a year. So £600, that was, you're getting into serious money. But that's just for a reasonable one. If you've got extra things, you've got extra terrain to negotiate, you're going to need some money. So they got into a very creative financing situation. And here's the thing with financing. You have nothing to mortgage. You couldn't go to the bank and say, well, we think we've got some good ground. We'd like to borrow some money, because the bank could say, well, what security? And they go, well, we hope there's gold there. And the bank would say, well, good luck. Banks were basically there to lend money on mortgages such as property purchases, that sort of thing. They were not in the business of, at least not until the no reliability legislation passed in the 1870s. But banks were not interested. So, how do you solve that? Well, they come up with a great system. This started in California, came to Australia, ended up in New Zealand. So, you have 2 sorts of shareholders. One is your sleeper shareholder, and one is your active shareholder. So, let's look at the sleeper shareholders. You find 3, so we're going to look at an example where there are 6 shareholders. You find 3 businessmen. This is a great photograph actually. That's William Jackson Barry, that's George Wellington Goodger, and that there is, I'm sorry, that's Barry. There's Barry, Goodger, and I forgot his name now, William Pike, the Goldfields Warden. But anyway, we've got 3 business people, and what they do is they contribute each week 1 worker's wage into the company. So they earn their money, plus they pay 1 person. Okay, now over here you've got 3 miners. And the good thing about these guys, they don't have to go out when it's frosty, when it's cold, when it's raining, when it's really hot, when it's horrible. These guys do. So each of these is paying a salary, and it's not that much. Each of these is drawing that down. Now the water race is finished, and they start sluicing. There are now 6 equal shares, right? These guys run the risk of losing all the money they put aside. These guys run the risk of wasting their time. So it was kind of an equal share, but when they work, all of them have a 6th share in the gold that comes in. And those shares sometimes could actually be worth quite a lot of money because, of course, all the money had been spent, so you were then measuring the value of your share based on how much gold was coming in. So if we look at one example here, we've got, this is in Bendigo. A lot of my examples are from Bendigo in New Zealand, the New Zealand Bendigo, named after the Australian one. But I tend to use that as my example. I based my whole PhD on that. So, what you've got here, the Aurora company, they mined this for around 30 years using their water race from Devil's Creek, which you can walk into the headwaters of it. But anyway, there's a couple of things I'll show you here. One is this is the equivalent of a 4-story building. That's really, really high. It was hugely profitable, but very hard to work. You'll see that the stones, this is quite distinctive in central Otago, you have to get the stones out of the way because they just block everything. And so they mined in here, the water races came around into here. Now, you've got something here called a boot, B-H-U-T-E, and those are quite distinctive in the goldfields landscape. What this is, you can see it kind of carries on along here. What you've got on this side, you have a sluicing company working with their guns. But they're going to work right up to the border with these fellas who are a separate company, and they're working from that side. Now, if you encroach onto your neighbour's land, they can sue you in the warden's court, and they can pretty well get away with anything. Oh, the land that they took, they mined areas that we know were paying probably 110 ounces of gold, and the judge might look and go, nah, I don't believe you, but we'll give you 60 ounces. Either way, it's 60 ounces you've just got because of another person's mistake. So, in that case, so what you do is you work up and you leave an obvious boundary. That's where these boots appear. So you'll see those throughout central Otago. I haven't seen them too many places in Australia. I think that's because of our greater use of sluicing as far as high volume goes. But, I mean, I might be wrong. So how do you actually get your water race? This, the main piece of equipment was that. It's called a foot level. And a foot level is something you take a sight over, and they got very, very good at sighting along these and seeing if the drop was what you wanted. You'd sit this on, you'd have stakes that were known lengths, and you'd basically sight along them and see if you are dropping too fast. You cannot have your water going too fast, okay? I'll come back to that, but water that is going fast is your enemy, not your friend. You want it fast at the end, not on the journey. So this had what's called a plum, which is made of lead. It was called plum because of the chemical symbol for lead. But anyway, chemical name for lead. Anyway, so they would build things that quite like this. Look at these guys. That cliff is at least 80 feet. Now, what's that? 26 meters high. And they're wandering around on there without seeming to have a care in the world. They've got corrugated iron that they've bent, and sort of got a framework up there. It looks the most Heath Robinson area. This is a place called Skipper's Canyon, and they are building a water race to quite a substantial mining area, and I'll show you in a minute where they ended up. But they built things like this. Now the problem is, if you're if your water source is way back, you have to get it to where you are using it by building a water race. So if there's a cliff in the way, if there's a gorge in the way, it's your problem to get around it. And these guys did. It's amazing. I've read when they built it, and no one died. So you'll see a complete lack of safety vests and probably no health and safety rules or anything. So they still actually, you still build water races that way. This is Ashmore Contracting of Cromwell, and that's actually a modern water race. They built it the same way. They just happened to use a laser level instead of the foot level. But, oh, by the way, this is also something you use in the quartz mine. You know, if you ever look at a quartz mine diagram, that's what they've used to actually measure the angles of the falls and that sort of thing. So, so when you're digging it, what you do is you dig out and you have water behind it. And if the water suddenly stops flowing, you're trying to go uphill. And that happened more often than miners probably wanted to admit. It happened in Bennett Boon once. And a lot of people lost a lot of money that way. But so you soften it and you carry on, and of course the water's doing part of your job, because if you're digging in clay, then the water is softening it and it's not quite so horrible. If you are going across a hill, this is above the town of Roxburgh. You can see these quite dry slopes, and they have ledges on them. Now those ledges would support, if you had the money, they were called sluices, where they were just a box sluice or a box flume that was kind of a U shape, and you would just make a whole series of these, join them together. If you tried soldering them, ice would get in there and break them apart. They were horrible to maintain, but it was worth it. So what you've got here is you've actually got two different fluming platforms where the water is going across. So the water is sourced over there and it's needed over here, and you have to get across the hill that way. Now what do you do if you can see a water race here? It's actually come from way over there, right around this corner, and then there was a flipping goat rock in the way. Well, you've got two choices: move it or cut it. And that's what they've done. They've actually cut through a rock to get that. Now if you hit a really, really steep gully, you've got no choice. This one here is in Otago. This is the Scandinavian water race, which led water from Matakanui to Drybread, and then also to St Bathans. And so the water here has to go across fluming. This is all wood. Now in central Otago, that meant vast, absolutely vast expense, because there's no trees in Otago. And they had to get all of this wood from Makarora. So they would cut it, mill it, put it in rafts and float it all the way, cart it from Makarora, from the mills, down to the edge of Lake Wanaka, put it in the water, raft it. That means people standing on it with poles, and raft it down to where you needed it, hopefully get it into the beach. They'd have men standing there with grappling hooks. Basically, poor guy standing on his raft would come hurtling down the rapids. These grappling hooks would sail out, they'd catch hold of it, pull it in, and then you've got your timber. The expense was vast, but this is how you build it. You've basically got to build it in sections, and then this very quickly will have water running in it. Again, why do you have water running in it? Because if the water stops running, you're not doing it right. So they would just build right across. Where the problem isn't, as far as they're concerned, all they need is to get water where they need it. So they're building it. So there was some where there was a canvas pipe. Canvas, you think, oh, that would leak. Not as bad as you think, because canvas, the fibres swell up, and if you have enough water constantly flowing through it, if it was strong enough, you could actually get water through a canvas pipe without any problem. They just suspended it on a rope and get it from one side to the other. If you visited the gold mining centre in central Otago near Cromwell, that's how they got water from Roaring Meg across to G's Flat. If you look at G's Flat, it's basically dry, and yet they did lots and lots of sluicing there. Well, it doesn't take a genius to work out they got their water from somewhere else. They bore it across using this technique. Sometimes they'd use, the pipes would be bituminized cardboard. That means cardboard that's coated in tar, which was a little bit more watertight. Either way, these were expensive. Now you look at that, I quite like this. This is again on Criffle Peak. And I don't know if you can see, but there is a water race has been carved out of that. And I'm picking they either used pipes, which was probably the case, they were a bit later in the rush, or, as I say, flumes again. But can you see the water race? How about if I put it there? Can you see it again? And the water race, it kind of looks like they're going uphill in part. It's not. But they've carved that out. Look, can you imagine trying to build around there? That is lethally dangerous and really hard work. So, and then the other thing, you've got to slow your water down. Now, two things are the enemy of your water race. One is turbine flow. So that's when you get water tumbling. If you get water moving too fast, going like that, you think, oh yeah, what's the problem with fast? It scours out the bottom of your water race, and then you've got leakage, and then you don't get the water to mine. The second thing is turbine flow, and that's when you get water that comes round in a curve and you've got it going too fast and it's going like this. Now again, it will scour things out. So you're coming down a hillside and it's going too fast, you are going to wreck your water race. You're going to constantly be fixing it. Well, this is an example up at Bennett Boon of a stepped water race. And what it is, I don't know if you can see it clearly enough, but there's a series of steps in this. And the water came down and was made to trickle. It slowed the velocity down. So controlling velocity was actually a major part. A lot of people have always said, oh yeah, water got its power from the slope. No, it didn't. So to get the water high pressure, what it is the water comes into a column that has a gradually narrowing series of pipes that forces the pressure. And that's where you get your monitor or your water gun or sluice gun. So here, this is an example of slowing that velocity down. That's right beside the track at Bennett Boon. Certainly recommend you go up, and that's again in Central Otago. So your water tower creates the power in your monitor, and what we've got here is, this is the Aspinall's Claim in Skipper's Canyon, and you can see the tail race here. That's quite a beautiful photo showing that process. Now, the sludge channel was Skipper's itself. Skipper's flows into Shotover flows into Kawara flows into Clutha, and everywhere along the way, the gravels, the sludge, creates problems. But anyway, this is the end result of that. You know that Heath Robinson sort of building around the cliff face picture that I showed you? That's where they're aiming. And it was hugely successful. Hugely. This is really, really, really rich ground. The other thing that you need to do, so you've got your water races here. Sometimes though, Central Otago is hot. In summer, your water runs out. So what do? Well, very simply, you build dams. So here is Menzies Dam above, that's at a place called Stewart Town above Bennett Boon. So here's Bennett Boon Historic Reserve, and they've built a massive, absolutely massive dam here. Now that had two advantages. One, if you are the owner of that, you can go mining anytime, so you'll see the water races here all come from that dam, and that means those who are working these gullies, which is where the gold was, can tap water and use it. If you own that, it's great. You can do the mining. If you own the water, you can sell that, and you've got a resource to sell. And you can see there just how intricate the systems were. Now, I've got another overhead picture, which I haven't used in this display, but there are holding dams all over this hillside where they've used this to basically conserve water. You want enough water. I mean, I've told you about the speed thing, but really volume also counted. You need volume to build up that head of pressure. If you haven't got enough water, then you can't mine. This is another little dam. This is a place called Rising Shine Basin on Thompson's Gorge Road, and you can see that dam there. And it's beautifully built. It's actually stepped. They've really engineered it for strength. So they've actually used techniques there that a Roman engineer would not be at all surprised to see being employed. So some things don't really change. So dams are important. And so then the most dangerous job on the Otago goldfields was this one. Now, here's what you have to do. You've got your hose man here, and his goal is to destabilize the gravels. He super concentrates the water in there, and it bulges. So you've got gravel that is inherently stable because of gravity. So if you put enough water in there, it loses the that stability and starts to move. So what you want is to get enough water in there that the gravel starts to move. And that's what you're doing here. You're putting it on here, the gravel's flowing here. Now these guys have a specific job, breaking up concretions by, what does that mean? Lumps of clay, gravel, and probably gold. So they have what's called sluice forks. You might have seen these. It looks like a pitchfork, but with extra tines on it, 6 or 7 tines. And they have 2 roles. One is breaking up those concretions. The second thing is keeping the gravel moving. So they're heading down to the tail race here. Now, most dangerous job, because of these fellas here actually put too much water on here. Instead of it loosening and flowing down, it bulges. And then if it bulges enough, instead of flowing down, it slumps. And these guys could be killed. The number one cause of death that I found in the Otago, I always thought it would be drowning, because a lot of people drowned in the Clutha and various other places, but they quite quickly built ferries and that sort of thing. So, but people, every single year, I found records of people dying from what they called a fall of earth, and must have been a horrible death. I mean, you've got your mates there would be charging and trying to dig you out, but I mean, if it was a big enough fall of earth, you were gone. So the work of these guys and the trust of these guys meant that, yeah, it wasn't easy. So the water was not just used once. You look at this, and oh yeah, they're using their water and then it flows out. Well, what happens when it flowed? This is at Dilmston, by the way, on the west coast. But what happens after the water's been used? Well, it can get reused. First of all, these guys, a group of Swedish miners, started the Come in Time water race. And that was right over a saddle in Manahirakia. Now, getting water over a saddle is not impossible, because if you think, a saddle's like this, so you start your water high enough, you can get it over the saddle. That's what they did. And this was a 12-head race. A 12-head race that's a small river. And they got the rights to this, they built it, they self-financed actually, which was interesting. They're one of the few I found that did that. But there was so much water, they were able to work in the upper part of their claim using their water guns, and then that would flow down, and they used it a second time a little bit further down the valley. So they're over this hill, that's Rise and Shine Basin, just to the east of there, and this is flowing into a new area here, and you look at this and think, well, how could you reuse it? Well, the answer is you carefully husband where it's going, you focus that water, and then you build a water race just there. Can you see it? It's a bit hard. You've got to look for these sort of unnatural straight lines. They build a water race here, and this gets used again by a quartz mining company, and then it gets used further downstream. This is the Rip and Tear Syndicate in Bendigo Gorge. They basically had this area blocked up by a natural dam. They clear this out, basically make this, they get water flowing through here again, and they set up a sluice box more or less here, and got some quite decent gold. Then it goes right across the flats and ends up, unfortunately this is now underwater, but Sam Williams gets the water at the gorge mouth, takes it right across the flats and mines these areas. And these are an example of, actually it's quite scruffy looking, but it's an example of alluvial mining, where basically they've lifted the rocks out of the way and done sort of just use the flow of gravity, focusing it on a tail race down the bottom here. And so that water has been used 5 times. And which is quite remarkable, really. So I made a comment about it becomes worth money. Now this is James Peace. He was I think I called them Come and Time. It wasn't. It was the Rise and Shine Basin. Come and Time was the quartz company. Anyway, he builds this asset and sells it. It was bought by a Māori miner. But anyway, he's selling this. He's selling his house and a 5th share in the Rise and Shine water race. And this sold, I think, for some extraordinary price. It was several £100 to the chap Mowat who bought it. You'll note here, it comes with a water rider, never failing supply from Thompson's Creek, giving the company a practical monopoly over many miles of known payable country. That's the asset there. So you've got the water race, you've got golden country, and you can buy a share of this. And he did. Gilbert Mowat's diaries are actually available online. You just look up Gilbert Mowat, and I think if you put Bendigo in there, you'll find it. So then the ultimate technology was the Venturi vacuum system that was developed, otherwise known as hydraulic elevation. It's used by, I don't know why, but some people call this gravel mining, the Australians do. But you've got a problem if you think about how your sluice gun works. How do you go below the surface to get your gravel and your gold out? Well, the answer is you can't. So they come up with a system, and I'm not going to go into the engineering of that, but essentially you are getting the gravels and it is coming up to the top there where it is processed. They've also got a sluice gun going here because they've got so much water. That was I talked about the Scandinavian water race earlier. That's where this ends up, at St. Bathans. And you can actually see here, this is a lake that used to be a hill. This is also where they're finding all those really unusual prehistoric remnants, like the huge parrot, the huge penguin, the tiny sparrows and sparrow-like things, and dinosaurs and various things around here, because they've gone so deep that they've uncovered bedrock that's got all these fossils in. But anyway, so hydraulic elevation, that is serious money. To get to that, you've got, first of all, a massive water race. Secondly, you've got the actual technology, and then you can see that there's a lot has gone into this. So hydraulic elevation, that was when they basically got to the point where it was companies doing the mining. And then, of course, water drove these. This is what's called a quartz mill, based on the technology out of Cornwall, and it's a crusher mill. Very simply, you have a wheel here that turns. It has a shaft with a series of curved cams those curved cams lift these metal shafts. You can see the curved bit lifts this under this collar, lifts it up, and then it's allowed to drop down. And if you, in here you have your rocks that contain quartz and ultimately gold, and it pulverizes those. It pulverizes it down to about eventually the consistency of talcum powder. So rocks down to talcum, imagine that. But water drove that. Here, these always seem to be 26-foot wheels, which is what? 8 meters. That's a pretty decent size. And I think basically what you've got there is the fact that if you've got a wheel that big, all you need is a bit of water on the top of it, and you've actually got a multiplication of power, because you've got a shaft going through here, translates to here, and you can actually end up turning this. So that's at Macetown, and this is in Bannockburn actually, at the Day Dawn. But they also water drove pumps, and water drove the actual lifting mechanisms to take gravel out. So water drove everything in terms of gold mining. And then of course the last thing that water was used for was to actually float dredges. Dredges needed water to operate. This here is the Bendigo Gold Light Dredge. This is the hole that was dug out by an unusual situation. This was in 1934. Total failure. Got about 40 ounces of gold in 2 years of operation. But this was going to be the great hope. This is why you do maths. Someone actually shifted a decimal point when they were doing the analysis, so they were being told we're getting 2 ounces per tonne of gravel, whereas it wasn't, it was 0.2. And that makes quite a difference. But anyway, they spent all their money on this. The hole here, which is filled by a water race, the same water race that, remember I showed you the Aurora syndicate and that with the boot? This is the same water race fed this at Bendigo. This hole was dug by 2 young fellas in the first ever contract they worked on together, and their surnames were Fulton and Hogan. So I suppose something good came out of that. But anyway, you needed water for that, so water again was used in dredging. All the developments in dredging technology were conditional on water being available to float the dredges on. So if you were in a river, then fine. If you were on dry land, as they are here, then very simply you need to provide a pond, and the pond was provided by, well, the pond was dug out, but the water was provided by a water race. Okay? That part there is still at Bendigo now. We arranged to have that shifted there and erected at Bendigo in the town of Wakefield. But the problem with all of this water-based mining is what it leaves behind, and that's called tailings. And tailings are particularly barren. There is no nutrient at all. Now, one of the things that I've found on the west coast is that tailings drain really well. So if you can put sort of a skin of soil over there, you don't get the pugging and the Pakahi swamps that they used to have. But it's barren. If you look here, they've actually used, this is actually an old tailings pile that they're using to film the Lord of the Rings here. And this is 140 odd years after it was mined, and yet it's still barren enough you can use it to create the idea of some sort of negative idea of scenery. The lines stay on the landscape. This one here intrigues me. These were 3 companies. This is on Criffle Peak. They did not get on. Why didn't they get on? I know that. Because if you look, if they got on, they would have built 1 water race and at the end divided into 3. But no, we don't like each other. So 3 water races are dug simultaneously. They must have, you sort of think, reconciliation would have been good, guys. You can actually see it here. Can you see the lighter green here? But those lines stay on the landscape. That's in central Otago. Those lines are still there. And then if you look in back to Bennett Boon, now remember I showed you this, the Menzies Dam. Look at all these. You can see the network. It looks really like, to make a map of this, you just drop a plate of spaghetti on the ground and you get all these lines. But you can see how the water races just crisscross all over that area. And so I'm standing here and facing this direction, and then I took this photo, and what you can see, I'm hoping you can see this in terms of the definition here, but you can see a whole series of lines, and each of those is a separate water race. Now, they wouldn't have all had water in them at the same time. They're different layers of mining. So this water race might have been the first, say, and then when you next need the one, you've got to start higher up if you're going further away. That makes sense, doesn't it? Because if you take it, if you're just going a short distance, you just cut it as low as you can and you get your water there. If you're going a longer distance, you've got to cut a longer one from the intake to get it right around. Otherwise, you can end up with your water too low when you get to your mining area. But anyway, so it's completely crisscrossed with these, and some of these are really, really big water races. But going back to Criffle Peak, here is, look at that, that is absolutely barren. These were mined in started mining in 1872, stopped mining in around probably 1886. This was mined for quite a period of time, and that land's useless. This isn't the most productive farmland you'll find, but that's not productive at all. So mining, actually, you can understand, in 1883, the Californian legislature basically voted and said, you're not doing any more hydraulicking in California, for that very simple reason. If you look here, this is stunning. This is the most photographed pile of stones probably in New Zealand. Well, this is now a historic reserve. This is a place called the North Burn Sluicings, and you can actually walk up there. It's about a kilometre walk, all uphill, to get to see it. But this here, these are what's called herringbone tailings, and this has been sluiced. But there was a lot of rocks. This was very, very rich. This is at Courts Reef Point. There were some areas there that were so rich they were nicknamed the jewellery boxes or jewellery shops. And these here, there's one area here that we were actually in a helicopter at the time. I landed just here, and you can actually see some areas here that show 2 layers of herringbone. In other words, you've gone through, you've stacked all the rocks out of the way, got all the gold, and then someone happens to accidentally go a bit deeper with their shovel and go, oh my goodness, we've actually got more gold that we could have found. So you go back and shift every single stone a second time so you can go deeper. Well, I suppose if there's gold there, it's worth it, but I think I would have lost my lunch at some point being told that. See the water race coming in there and doing the work. So this carries on. There's blowdown sluicings here where they actually use the bywater. That's the water that had been used. You can see the central part here. This is where the tail race was built. But where the water was basically waste, you'd have other guys here using that to try and get some surface gold. Frenchman's Point. This is spectacular. This was, it's called Frenchman's Point because it was mined by Frenchmen. It was Jacques Bladier and Jean Desire Ferrot, and they were the main shareholders. But this is early days of Manahera Junction. Later became known as Lower Dunstan. Later became known as Alexandra. And Frenchman's Point, they mined this for 24 hours a day at one point. This was in the 1860s. And this was 66, 67, 68. They mined this point, and they mined it even using lights during the night. And what they would do is they would dig gravel out, run these big long toms, and just pour it into the Clutha. So that's Frenchman's Point, but this is Frenchman's Point now. So I have not managed to get the photo looking on the same angle, but this is an aerial photo. You can see this is quite high, right? It's gone. It's completely gone. It's been mined away. So that's there is this, well, it carried on a bit out into here too. It's gone. But this Frenchman's Point, they've just dug it out. It's gone into the river. And so that's quite substantial. That's all hydraulic mining. That's all sluicing. And then you look at Bennett. Now, isn't that there? See that you've got from the two different angles? That's another one of those boots I was telling you about. And the unique thing about this one is it's triangular. So you've got someone working from this side, someone working from this side, and someone working from this side. But you imagine, here's our level. Where's all that gone? All that's been mined, all that's gone down, all that's gone into the Quorra River, and then from the Quorra into the Clutha. Well, what causes a problem with that? Well, for one thing, it leaves it absolutely barren. This is where the last scene in that Pavlova Western Good for Nothing was shot. If you haven't seen that, get it, download it on iTunes. But also, this is where you can end up with Mordor and all sorts of horrible things happening. Basically, if you mine an area, it can be used as a horrible mountain. Makes sense? And then look at this for, I think we're the only place in the world that took a dump. Seriously, that's what dredge tailings are. Took the dredge tailings of the Earnscleugh dredge. Now this operated right through into the 1970s, so it operated for a long time, and turned it into an historic reserve. So this is a photo I took, standing on top of one of these hills, and it just goes on for vast, vast areas. But again, look at this, nothing is growing there at all. This was a photo taken at the time the dredge was still operating, and this is 2016, I think I took it. But again, this is the mess that water mining leaves behind, or water powered mining. So what's the end result? Well, this is Alexandra. In 1995, the problem I've got is that this riverbed is not deep enough. Why is it not deep enough? Because it's lined with gravel from there. So water's flowed down, it's been deposited on the river bottom, and when there is a peak flow, it ended up flooding the whole town. And that there's the historic Bendigo Hotel, and when they built a stock bank, they decided that it would have to pay the price and was knocked down. Alexandra's quite good at knocking down its Goldfields heritage, but anyway, they built a stock bank here, and I think they've done a bit of dredging in the river too. But that's a direct result of sluicing for gold using water-powered mining since the 1860s that this flood happens. The water races themselves still have use. Mount Difficulty is one of many. This is, you can see Bannockburn, so I've taken these Stewart Town up here. I've taken a lot of photographs around there. But Mount Difficulty have a never-ending water right. It does end, actually. It ends in 2021 thanks to the provisions of the Resource Management Act. But those water races have actually been used in a number of cases to actually grow Central Otago wines. I'll just show you this one at the very end to show you how long water-based mining remnants last. This here was mined by a chap called Julius Caesar. It's in... I'm going to do terrible at my Spanish here, but that's La Medulas, something like that anyway. But that was mined at around 300 BC and around that sort of area when Julius Caesar's doing his thing. So, and that provided the money that meant that he could go and be emperor and all that sort of thing. But you get what I'm saying. So this is Bennett Boon. That's 2,000 years ago. And you can see also that what we've got is a water-powered mining remnant. And here we've got a water-powered mining remnant. And the end result is quite interesting. So if you've got any questions, you can email me, lloyd.carpenter@lincoln.ac.nz. My contact details are all on the Vimeo homepage for me, but I welcome your questions and comments. Cheers!